Let's first start by solving by completing this square. So we've already talked about completing the square when changing in quadratic equation to vertex form, and this works very similarly. So just a quick reminder, whenever you are squaring a binomial, it follows this pattern where whatever our a was, this middle number, or your b, is going to be 2 times a, and then your last number would be a squared. So because of that, if I have something like x squared plus 6x plus 9, this follows that pattern, because if I take 6 divided by 2, that's 3, or 2 times 3. And then if I take that number squared, that is 9. So I have that same pattern that I have right up here. So that means I can rewrite this as x plus 3 squared. All right, so let's talk about how to solve problems using this method. So for this first one, I have x squared minus 5x equals 3. I need to first complete the square, and to do that, I need to force my left side of the equation to match that pattern that we just talked about. So I'm going to take half of negative 5, which is 2.5, or I'm going to leave it as a fraction, negative 5 halves. And then I'm going to take that number and square it to complete the square. So I'm going to add in 25 over 4 to the left side of the equation. And now this is a perfect square trinomial. Because I added to the left side, I need to also add to the right side to keep my equation even. And then we can rewrite this. So now my left side of the equation is x minus 5 over 2 squared equals, and then the right side of the equation, I'm gonna change this to 12 over 4. So this will be 37 over 4. Now the reason I'm going to do this is because now my x is in one spot, which means I can solve for it using inverse operations. So I'm going to do that now. So first, let me move it over here. X minus 5 halves squared equals 37 over 4. So I'm going to square root both sides, and I get x minus 5 halves equals plus or minus the square root of 37 over 2. If I add 5 halves to both sides of the equation, I get x equals plus or minus square root 37 plus 5 all over 2. And those would be my answers. All right. Let's look at another one. So as you might remember from vertex form, before we can complete the square, we need to make sure that x squared has a coefficient of 1. So I am going to divide everything by 3 to cancel that out. So I have x squared plus 4x equals 6. And now I can go ahead and do completing the square. So for this one, half of 4 is 2. And then 2 squared is 4. So I'm going to add 4 to both sides. I can rewrite this as x plus 2 squared equals 10. And now I can take my equation and solve it. So x plus 2 squared equals 10. Square root both sides. X plus 2 equals plus or minus 10. And then subtract 2. So x equals positive 10 minus 2 and negative 10 minus 2, which comes out to 8 and negative 12. All right, let's move on to a different method. So let's talk about the next one, which is solving by factoring. I tend to think this is the easiest way to solve quadratics as long as it is factorable, and we'll talk about if it's not factorable later. So factoring, this should be a quick review, but there's 2 different methods. When a equals 1, it's a little bit easier, but the first thing I need to do is get my equation equal to 0. So I'm going to move 40 over to the left side of the equation. Minus 40 equals 0. And then to solve this, I'm just finding factors of negative 40 that add up to 3. So that would be 8 and 5. I need one of them to be negative. So 8 minus 5 gives us a positive 3. And then I just write this as x plus 8, x minus 5 equals 0. Once I have it factored, it's very easy to solve. We're just going to take each of these factors and set it equal to 0. And we get x is -8 and x is +5. All right, so let's talk about what happens when we don't have a coefficient of 1. So same first step, I'm just going to take my -7 and move it over. So 4x squared minus 16x plus 7 equals 0. Now, instead of looking at 7, I actually need to multiply a times c, so 4 times 7. So I'm going to look at what factors of 28 add up to -16. So we've got 14 and 2. I need a positive 28, which means the signs need to be the same. This is -16, so I'm going to make them both negative. And just to check it, -14 minus 2 is -16. -14 times -2 is +28. So now that I have that figured out, we do what's called split the middle. So I'm splitting my middle term using these two numbers. So -14x, -2x, plus 7 equals 0. I haven't changed this equation because -14 and -2 still add up to -16. I just split them apart. From here, we can factor the rest of this by grouping. So I'm going to group here and here. I can take out a 2 out of this first group and an x. So this is going to be 2x minus 7. Out of the second group, I can just take out a -1, and I'm left with 2x minus 7. And then finally, I can factor out 2x minus 7 from both. So I get 2x minus 7 times 2x minus 1 equals 0. And then we set them both equal to 0. So we've got 2x minus 7 equals 0. 2x plus 1 equals 0. So x equals 7/2, and x equals -1/2. So our last method is solving by using the quadratic formula. This will always work no matter what your quadratic looks like, so it's foolproof, but it is a little time consuming. So I always try to see if it factors first, and then if it doesn't, I fall back to quadratic formula. So we're just going to use this formula and plug everything in. In this case, A is going to be 1 because there's nothing here, so that's a coefficient of 1. B is -6, and C is 4. And then I'm going to plug straight in. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. And then we just simplify everything. So x equals 6 plus or minus 36 minus 16 over 2. 6 plus or minus the square root of 20 over 2. Because we are in SL Math, we should know how to break down our roots. So 4 goes into 20, which means I can write this as 2 square root 5. So this would be 6 plus or minus 2 root 5 over 2. And then they're both even, so I can reduce everything to 3 plus or minus the square root of 5. So in this video, we learned how to solve quadratics in a couple of different ways. First, we did completing the square. Second, we did factoring in 2 different forms. And then lastly, with quadratic formula. Thanks for watching.